I welcome you to this tutorial video. In this video, we'll be looking at the complement of binary numbers. And when we say binary numbers, we know they are associated with digital computers. So the complement of binary numbers are used to simplify the subtraction operation and for logical manipulation in digital computers. So basically, there are two types of complements of for each radix. So they are the radix complement and the diminished radix complement. So the radix complement can be written as the arrow's complement, and the diminished radix complement can be written as the arrow minus 1's complement. So in this video, we're looking basically into the binary system. So the radix complement in the binary system is known as the 2's complement, while the diminished radix complement in the binary system is known as the 1's complement. So we'll be picking examples, and we'll be finding the 1's complement, and also we'll be finding the 2's complement. So let's proceed. So let's take on our first example. So our first example, we are asked to find the first complement, or let's say the 1's complement of this 4-bit binary number 1101 base 2. So basically, in the 1's complement representation, you simply convert all zeros to 1 and all 1 to 0. So 1101 base 2. So the first the 1's complement, is since this is 1, this will become 0, this is 1, this will become 0, this is 0, this will become 1, and this is 1, this will become 0. So it is as simple as that. So wherever you have 1, you simply write 0, and when you have 0, you write 1. So that is that about our first example. So let's proceed with the second example. So here we are asked to find the 1's complement of 1011001. So we have 1011001 001 base 2. So the 1's complement is the 1's complement is, so wherever you have 1, you are going to substitute it for 0. So we have 0, this is 0, we have 1, this is 1 1, we have 0 0, and this is 0 0, we have 1 1, and this is 1, we have 0 base 2. So that is that about the second example. So let's proceed to the next example. So here we are asked to find the 2's complement. We are asked to find the 2's complement of 11001. So basically, in the 2's complement representation, all you need to do is to find the 1's complement of the given binary number and then add 1. So you can basically say 2's complement is equals to 1's complement plus 1. So what the first thing we are going to do here is to find the 1's complement of this given binary number, and then when we've succeeded with that, we are going to add 1. So let's proceed. So we have 11001. So let's find the 1's complement of this number. And how do we do that? Wherever you have 1, you put 0. So this is 1 1, we have 0 0. This is 0 0, we have 1 1, and this is 1, we have 0. So since we'll be able to find the 1's complement, all we need to do now is to add 1. So we can simply add 1. So since this is a 5-bit binary number, to make it look nice, we can have 0 0 0 0 1, and then we can perform our addition. So it's 0 plus 1, that is going to give us 1, and 1 plus 0, that is 1, and 1 plus 0, that is 1, 0 plus 0, that is 0, 0 plus 0, that is 0. So we can put our base 2, base 2, base 2, and base 2. So our 2's complement is equals to 0 0 1 1 1 base 2. So let's move on to the the last example that we have. So here I'm going to be using a formula to solve the last example, and the formula is applicable to radix complement of any base. It can be base 2, can be base 8, can be base 10, can be base 16. So this formula is applicable, but here we are only looking into the binary system. So this is the formula where we have r raised to power of n minus n, where r is equals to the radix and n is equals to the number of bits, and n is the given number. So this is you're asked to find the 2's complement of 100n. So the n here is 1001 base 2. So this is the number we are converting. So what is the radix? The radix r is equals to 2. That is, the radix means the base. So the base is 2, and the next thing we are looking for is our small letter n. Small letter n is the number of bits. So how many bits binary number is this? This is a 4-bit binary number. So now that we've known our n, our arrow and n, so let's substitute them into our formula. So we have 2 raised to the power of 4 minus 1001 base 2. So 2 raised to the power of 4, of course, that is 16 minus 1001 base 2, and this is 16 base 10. So we can simply convert this to base 10 also. So 16 base 10 is equal minus 1001 base 2 in base 10. I think that should give us 9 base 10. Yeah. So 16 minus 9, that will give us 7 base 10. That will give us 7 base 10. So remember, we are dealing with binary, so we'll convert 7 base 10 to binary. So 7 base 10 in binary is going to give us 111. So remember, we're dealing with a 4-bit binary number, so we can put a 0 here to make it a 4-bit binary number. So we have our base 2. So the 2's complement of 1001 base 2 is this.